Okay, so like we have given the array and the array size, and we have to find the bitwise end of all the integers. So we can see that we can find it by two ways. Like one, it a brute force approach. Like we can run a loop from I from 0 to n, and similarly j I plus 1 to n, and then we find the whole combination like. And sum of all sum plus equals to ARR of I and ARR of j, and we return the sum. First we have to initialize sum also. Okay, so like this is the first way. So now we see the second approach that we can use. Okay, so like we can see that we have to solve in big of n time, that is given that expected time complexity is big of n, and constant are also n, and value is 10 ki power 5. So we have to think in that way, like how can we solve it in big of n time. Okay, so like let's see if we can see the first example. 5, 10 and 15 we have given. So binary number of 5 is 0 1 0 1, and binary number of 10 is 1 0 1 0, and binary number of 15 is 1 1 1. Okay, so what we can see from here, like we can count the frequency of each bits we have, because maximum the 32-bit number they can give us. So like frequency of one here is 2, and one here is also 2, here is also 2, and one here is also 2. So like we have to take these number and think that how can we generate our solution. Like we have to generate 15 from this by using this frequency, because in most of the questions of like bitwise or and we have to solve that in big O and time complexity, then we have to take care about the frequency of the elements. Okay, so like we have to make the pairs of the element. Okay, so like there are two times the occurring one in the zeroth bit. So like how many pair we can generate generally from, like if there are n number, then we can generate the n c2 pairs. Similarly here also, like there are two pairs, so 2 c2 means one pair we can generate from here, one pair from here, one from here, and one from here. So each can generate one pair of number. Okay, so like one pair. Okay, then like there are one pair at initially starting point at, there are only one pair. Okay, so like one pair into power of 2 ki power 0 plus. Okay, understand, like we are multiplying their number into 1 into power of 2 ki power 1 plus 1 into power of 2 ki power 2 plus 1 into power of, sorry, 1 into power of 2 ki power 3 also. So it's give me 15. So that is my answer. So like it's we have to calculate the frequency of each, like there are maximum 32 bits, so like at each bit we have to calculate the frequency, and we have to multiply it by that number. So like there is one here, one, because we have like from two numbers we can make one pair only. So like if we derive the formula from nc2, then it comes out to be like n into n minus 1 by, sorry, n into n minus 1 by 2. So these number of elements we can generate. So like in the place of 1, we are at the place of n we are putting the particular bit frequency, and then we can add all those. Okay, so like let's see from the code. So first we initialize a variable long sum equals to 0. Okay, then we traverse the whole bit for int uh, int I equal to 0, I is less than 32. Okay, I plus plus, because maximum the 32 bit number is here. Okay, so each time int k equal to 0, like we have to take it long k equal to 0, because we have to calculate the particular number is bit or not at that point. Okay, so like we can initialize another loop j plus plus. We shift the particular number, like if arr of j and 1 is less than I. Okay, if that is true, then we increase the count. This is basically shifting the 1 by I times and taking and with that. If this is true, then the bit number here is true, like in at this place 10101. So if we take the rightmost bit, so it shift 1. Okay, so it shift 1 by 0 times, then it will take the end with this, so this comes true. So we increase the count of that, and finally we include that in our answer. Is sum plus equal to our generated formula, and that like power 2 ki power 1, so that we can return this format, that 1 is less than I multiplied by our count for that particular, multiplied by k minus 1 divided by 2. Like it's basically the this formula we that we are derived, we are using that formula here, and finally we are returning the our sum. Okay, so first we comment out these stuff, and in like let's see one more time. Like first we initialize our sum variable that we have to return, then maximum 32 bit number can be here. Okay, so we are checking each bit and counting the frequency of that bit, and multiplied by 1 is less than I, that is this number power we are saying. Okay, and that are the number of pairs that we can have, and finally we are returning our sum. Okay, let's see it's compiled or not. Okay, so like we are doing the mistake of one curly braces here, that is wrong. Okay, so like it's giving me the correct output. Let's submit this. I think that all test cases should be passed. So all the test cases are passed. So thank you. Let's see you in the next video.